Okay. Um, so for project updates, we released Karpenter v1.8.0 with support for static capacity. So I don't know if Sumukha is here if he wants to talk a little bit about it. Okay, I don't think he is. But anyway, so we release support for static capacity. We release support for allowing users to set IP prefix count for pre-warming the IP prefixes. Derek, do you want to talk real quick about it?
Yeah, sure. So the preforming prefixes is a EC2 feature mostly, or it's a AWS provider feature. So I'll always allowed, we always pass through the launch template whether or not you're using IPv4 or IPv6, and now you can additionally set a field that tells how many prefixes to allot to each new node on startup. So it should be linked to the lifecycle of the node. The benefit here is when you know you're going to need the IPs, you get faster startup times. This work was originally done for the EKS Ultra project that we were working on, and we found that at those kinds of scales, you couldn't scale up at the speeds we wanted to while having to wait for the VPC CNI daemon set to allocate prefixes. So if we got EC2 to do it for us, it was much, much faster.
I see we have a raised hand by
Yeah,
Cameron.
I just have a quick question about this new feature. Do we know if this IP prefix to pre-warm works with CNIs other than AWS CNI? Like Cilium, I know already supports uh, IP prefixes with AWS. Do we think this feature would work out of the box with Cilium, or would Cilium have to do something to make this play well?
That I don't know. That's a great question.
Okay, well, we'll probably test it out and report back then.
Yeah, please do. I would love to know.
All right. If there are no more questions, we can go ahead and talk about the RFCs. The first one is price improvement consolidation factor.
Hi. I'm not sure what the flow of these normally goes like, but yeah, so I am currently facing some issues when running Karpenter where it basically just leads to a lot of node churn, which then has the downstream effect of lots of pod interruption. The link GitHub issue is kind of covers it in more detail, but the proposal here is to add something similar to cluster autoscaler's approach, which uses a utilization a flag that you can set so that in order to trigger a downscale, some utilization threshold must be met. And so looking at Karpenter, I'm proposing that a cost improvement factor be considered before consolidating a node. So as an example, if you set that to something like 20% instead of the like current, which would be 0, you could end up with a little bit less node churn for those small incremental price improvements.
Yeah, this is something we've considered in the past quite a bit. I think it's been bandied about before as a lever to give people for consolidation. It's definitely probably one of the ones we're going to end up doing. We've been doing some work on the AWS side to try to get some better data around this. The idea being letting a user configure this is nice, but is there maybe some way we can be smarter about this and not decide it for you, but know based on the size of your cluster how reasonable disruptions are. I don't know if you're going to get away from a configurable for OSS customers specifically, but it has been something that we're definitely considering. So I do like to see this kept. I think it's a good place to have the discussion. If you have it'd be nice to see how it works with cluster scale, if that makes sense. For
What do
a
you mean?
very,
Like,
very like the price threshold. So if you have like 1,000 nodes versus 5 nodes, your price improvement threshold is going to be very, very different depending on the two of those, right? Because you would probably want a tighter threshold for a larger cluster and a bigger threshold for a smaller cluster, because otherwise you'll never get disruptions for a small cluster, or you'll never get disruptions for a big cluster, or you'll get a lot for a small cluster, if that makes sense.
I think it might be, yeah, that totally makes sense. Thank you for that. I think it'd be more so based on either the node pool or looking a little bit deeper at the particular workload that is trying to avoid disruption, because it totally depends on that, right? So for yeah, and not necessarily cluster size either. If you have a bunch of stateless applications, or maybe not even that either, but if you have a bunch of services that take zero negative impact from being rescheduled or shifted around, you don't really care about this, and you'll just keep it at zero. However, if you do have something that needs to warm up a cache, or has like it's intangible, but sort of any negative effects associated with rescheduling the pods, that's where you'll want to tweak this. And it's probably not even a one size fits all for the entire cluster. So even for the large cluster example, you might have one node pool that has a 80% threshold, and then the rest of the nodes stays at 0. And then that single workload targets the one with a higher threshold. Maybe you don't add taints to it or anything, and then other workloads can run there too, so you still get most of the benefits. So like, yeah, I think there's a lot of trade-offs to consider based on the user. So I push back a little bit that there's any way for someone to sort of automate this based on the cluster. I mean, it'd be nice to maybe like take a shot in the dark and have something that's like directionally correct, but I would love to have this configurable.
Yeah, so that raises a very, very interesting point that we've also considered. The main reason why folks have been reticent to do a consolidation improvement threshold specifically is because it does tend to be a proxy for this other kind of stuff you're talking about, right? Like it's a proxy for these workloads are expensive to disrupt and those workloads aren't. And so like, I don't mind if you disrupt those, but I do mind if you disrupt the other guys. And so then we've banded about like a different type of configuration where users can instead say how expensive their workloads are to maintain relative to each other, and then Karpenter can be smart on consolidation using that instead. So we can respect what the actual customer use case is, not like we've been reticent to add configuration in Karpenter that's just like tweaking the algorithm, and instead trying to add configuration in Karpenter that lets users express their intent, and then we do our best job in satisfying that intent rather than having them have to do the kind of thinking of like, oh, well, do I want to set this number high or low given my use cases? And do I have to like put these pods on specific node pools? That way I can set that node pool's threshold higher. Like that kind of nitty gritty configuration is something we've been trying to avoid in general.
Yeah, I think it's also just difficult to predict some of the second order effects of changing these. Yeah, basically changing these factors. Like one of the things I know we've noticed with consolidate after is you actually have cases where increasing consolidate after can increase pod churn rather than decrease it, because it ensures it really is a proxy for minimum pod lifetime, and it ensures that newer nodes which potentially have few pods can't get disrupted, where older nodes with lots of pods that might end up getting moved over to those newer nodes. So those are kind of the second order effects that, at least before we take in a feature like this, we need to make sure that we're thinking through and seeing what sharp edges they present.
So I guess what might you be suggesting as an alternative here then? So like, I guess like currently with consolidate after, you're right, that's basically a way to guarantee minimum pod lifetime, but it's also a way to sort of push out when node churn will occur. But then, yeah, just like you said,
it doesn't in practice, though. It is really just minimum pod lifetime. And that's, I think, the issue is by, at least with consolidate after, is by exposing this field, which is specifically like impacting some of the timing in the algorithm, people might think it does one thing, but it actually does a different thing. Like the naming is almost a little bit misleading, and it makes it hard to express your intent through it.
Could you possibly explain that a bit? I'm not understanding how this differs greatly from something like the cluster autoscaler example.
I think cluster autoscaler, you're also dealing with a little bit of a different problem in that you're thinking about utilization over an entire node group. Whereas here with like a price improvement factor, you're thinking about from one consolidation decision, how much of an improvement can you make? But the issue is that you may need to make you may have room for like 80% improvement, but you need to make n consolidation decisions to reach that. So that's where I think it is. Like I said, I don't have an answer now, but these are the things that we would want to think through.
Okay.
Can I
So-
ask
so, like-
some?
Good.
Sorry, I interrupted. You go. You go.
Karpenter respects things like pod deletion costs today, right? So that's one way that you can influence some of the consolidation, I thought. But yeah, like I'd be open to something else. I would just very much like to help contribute towards a fix to the problem of avoiding interruption to or being able to control how much interruption goes on in the cluster. I think that GitHub issue has been open for a while. If there's an alternative, that'd be great to hear. But I'm not sure there's yeah. Is there something better that maybe I could help drive the solution forward?
Yeah, I think we've gotten off on a little bit of the wrong path here. I do think a price improvement threshold is going to be part of the final solution. Like I think we're all aligned there, right? That some kind of like don't make a decision that isn't meaningfully impactful to my cluster is going to be there. I want to know. I want to know more about your use case here. Is the issue you're trying to solve is that like your pods are getting disrupted when you don't want them to be, specifically your pods that are like costly to disrupt. Yeah.
That is one example, yes. But yeah, let's go with that.
Okay. If there are other ones I'm missing, please. I do want to get a better understanding of like both your use case and like we have a whole bunch of people here. I know that we've seen a lot of people have issues just with node churn in general. Maybe it's like licensing. They don't like having to keep doing that. Maybe I know we've heard from some customers that are saying like, oh, we have very, very expensive startup times for our things because we need to hydrate from some external service. We need to hydrate our cache, and that is expensive every time you disrupt our pod, and we'd rather you not do that. So I want to make sure that we're getting your use case captured in the conversation.
That is definitely the simplest example to stick with. There's others like just wanting to avoid node interruptions in general, or node churn in general rather. If we're working in a region that like AWS in particular that doesn't have a lot of a certain instance type and we're running on demand, if those go away and then some other customer ends up taking them, now we have to run either a more expensive instance type or some other instance type that maybe we don't prefer. So like that's like there's sorry, I don't have the entire list ready to go through, but the wanting to avoid node churn because of expensive pod interruptions is probably the easiest and the one that I think affects the most number of users currently.
Okay. Yeah, the keeping instance types that are hard to get a hold of around is a very, very, very interesting one. I don't know if we've talked a lot about that one. But on the like these pods are expensive disrupts, I wonder if there isn't room here for a cap instead that's talking about changing our disruption cost calculation for pods. Right now it's pretty simple. I think I looked at it the other day. It was just like we calculate it as one for every pod unless you set the specific annotation on the pod that would let us input that. I would love to know if that has a better use case there for like, but that I'm talking over myself here. The hard part about that is right now our pod disruption cost, I don't think will prevent disruptions. It'll just prioritize them. So I do wonder
Exactly,
if there's
yeah.
I wonder if there's a supplement there where it's saying maybe we can do a disruption cost threshold, like an internal one that's sort of just like don't disrupt pods that cost too much. But I wonder if that doesn't have weedy problems as well.
Yeah. Or maybe there is like a way that we could evaluate, because I think one of the issues I potentially see is if you're doing one by one decisions, Carpenter, like improvements are made over cumulative decisions. I wonder if there is a way we could figure out like what is the cumulative possible benefit that we could get from consolidating a cluster and just turn off consolidation when we're below that threshold. Like I think that may be what's kind of missing today.
I guess to chime in a little bit, I think I have a similar answer. I just don't know how to articulate it. But I think for better or worse, the only number that's easy is cost, unfortunately, meaning it might be expensive. It's like we want back pressure from deleting certain things, but the only way to tell Carpenter, hey, don't do that right now is like cost. Like, hey, it's expensive for me to like churn this pod. And the only way to express that is like maybe a dollar amount or a cost amount uh, to prevent so that like, oh, from Carpenter's side, if I consolidate this, if I add up the cost of the nodes plus the cost of the pod churning, it's greater, therefore don't consolidate. Like I don't know of a cleaner way to put back pressure back on consolidation dynamically that isn't at the cost. So I guess I understand the price improvement, even though I don't have a direct dollar amount for like this pod cost this much to churn. But I want to inform Carpenter in some way, and it seems like the only way is like from dollar amount, if that makes sense. At least at this time.
Yeah, that's where most of the conversations around like a better pod disruption cost go, is it's
Right,
like,
right.
okay, well, what is the nominal unit and how do I as a customer
Right.
know what to set it to?
Yeah.
Which is where then we've had some discussions of people then saying, oh, maybe we can discover your pod disruption cost for you by like using pod ready time as like a proxy for saying, okay, if your pods take longer to go ready, that means they're more expensive to disrupt because they're not doing work while they're ready. But that doesn't catch second order
Yeah.
factors of like, okay, but there is literally a dollar amount because every time I have to start a pod, I like call service A that costs me $1. So I'd
Yeah,
rather you
yeah.
not call that, you know?
Yeah.
It's hard because
Yeah, it's not obvious.
so
I agree.
really
It's not obvious, yeah.
I want to make it clear, Isaac, that this is like an important conversation to have, and we're very glad that you brought this up in a way that we could have this discussion, because it's not like I don't want you to think that this is like feedback where we're all like, we hate this is bad, nobody wants this. The problem is that like we do want to solve this problem, and we're just not, there's no perfect solution. So we might end up just having to go with something that's okay in the short term. I would like to know, do folks think that this kind of price improvement factor threshold thing would be something that would stick around forever, or is this something that folks would want to see as a short-term thing and then that we deprecate later?
Could I add a quick one thing I wanted to add on top of that was I don't think we necessarily have like this could be solved both at the granular pod level as well as the cluster level, which is what I was trying to accomplish here. But yeah, I'll go ahead and let people respond.
Are we talking like when you talk about this staying around forever or whatever, are you talking about like the ability to have some sort of like being able to inject this value that would, this scalar that would allow you to say, okay, ignore prices that are less than this percentage or whatever? Like, is that what you're talking about?
Yeah, this proposal here.
Well,
Yeah, I
or-
can see it being useful. Yeah, for sure. I can see users wanting this kind of thing. Like, I mean, unfortunately, I don't have any data right now of users actually wanting it, but it seems useful, right? Because you're going to get into situations where people are going to say, "Why did Carpenter, consolidate my cluster? These nodes were only, 2 cents an hour less or something like that, right?" And then they'll say, "Okay, well, we want to be able to have it not do that, basically." So I could see this being useful in the future.
One more there's also a lot of users of Kubernetes who might not be experts on Kubernetes or Karpenter or know how to set some of these values that we're talking about implementing at the pod level. So in turn, that's just going to lead to cluster owners or operators then setting those same annotations or however that gets implemented for the users. And sometimes maybe a cluster scoped flag like this is good enough or all that they really want.
I guess from my perspective, at least at the cluster level, it it's in the right direction. I just don't think I understand our cluster enough to be like, what is our ratio supposed to be? Like, I can't understand that changing the ratio to a certain number means how many less disruption. Like, I can't, it's hard for me to put the two and two together. And maybe it is supposed to be simple that like, oh, we set some number and we see what happens. Um, it just the effect is so, I don't know, unknown after you set the number. But I get this knob. Like this knob makes sense to me. I just don't know fully when it's like a price number, what it translates to for us, if that makes sense.
Yeah, and I think that could be one of the benefits of a more intent-based solution around this. A, because it might be a little bit easier for users to reason about, but B, because we can tweak the underlying implementation as we go to better match that intent. Like, I feel like that might have been one of the misses with Consolidate After, was that there was an intent around it. I think users can misunderstand exactly what the intent of Consolidate After is, but because it's very closely tied to what the underlying algorithm does, there's not much we can do to change it to better match the intent of users.
I think that makes sense to me. Like, I guess in a way, it would be nice, and I don't know the answer to this, but like it would be nice if I can like at a cluster level, like prioritize certain consolidation that I know is cheap or less costly for me, and don't do it if it's too expensive. I just don't know what that knob translates to, but it just feels too very restrictive as a dollar amount because it might be like a percentage that makes no sense to set. But if something more like I don't know, like I guess the intent based, like some other variable that's more like nebulous, maybe it'll make more sense in terms of a knob for changing versus like oh a dollar amount percentage because I don't even know if I can. It might be like a 0.0001% for me if that makes sense. Yeah.
I wonder if, as a short-term thing, we could, I hate to say metrics are the answer because they're not going to actually solve the problem, but it does seem like we do need some data or a way to give users the idea of like how much does Carpenter think it's consolidating your cluster by in order to do something like this. I wonder if we couldn't, if whatever solution we end up going with, if it's a threshold in terms of like a percentage or if it's a threshold in terms of like a price value, like only do it if it actually improves my cluster price by this amount. I do wonder if we couldn't just tool some metrics around that where you start off giving Carpenter like buck wild free reign and then you go through and you say, okay, well, the majority of the decisions are like, I want it doing like less of the decisions. And so you get to see what it thinks it's doing and know to tweak the knob to that value might be the way that the system informs your configuration of it in like a nice cycle. Um, I think there are ways to solve that kind of like, how do I know what to set it to problem for a threshold specifically. I don't know if on a pod disruption cost level, if that's just the same. Like if you're going to set a pod disruption cost annotation or whatever, I don't know if that has the same kind of feedback mechanism where Karpenter can say like, oh, I wouldn't have made this decision if you had set that pod disruption budget, this pod disruption cost to slightly higher. I guess you would. Yeah, I guess you would. I guess you could do that. You could log the metric of the right hand of the equation, being like Carpenter consolidated this because it thought that the gain from consolidation was X versus the cost was Y, and you could see the difference, and you could know what to tweak your values by to prevent it from doing consolidations that you didn't want to do. Are people following, or have I lost? Have I lost you?
I think more or less.
Yeah, I think that makes sense. It just comes down to still what the implementation of the knob would be.
Yeah.
I think this is where it makes it like tough for me to evaluate this from the perspective of like I don't have any users kind of asking for this at the moment, so I'm not quite sure what the expected what the expected experience is going to be and how someone would interact with this, right? So it makes it tough to kind of evaluate some of the specifics of it, you know.
Could you maybe pull up that linked GitHub issue? Do you not think that this would either resolve or at least assist with that? Because I feel a lot differently about that. Like this has been open what I don't know, October 24. It's got a good amount of thumbs up and lots of comments on the issue. Like I don't think this is a low impact or something just being requested.
No, definitely not. I'm not saying that. I'm just saying I'm having trouble, visualizing some of the question, some of the like, how do we answer these questions? Like what is the value that gets put in there or whatever? I'm having more difficulty on that. And maybe I need to go back and review this issue again, to kind of refresh myself. But for me, it's different. Like, I think this is a useful feature. I could see it being a useful feature. But if someone were to ask me, like, what should the value be, or what should the number be here, for example, in the not the consolidate after, but like the factor, how should that relate to it? It's like, well, I have a much less strong opinion on that because I don't currently have like a strong visualization of like how I would use this in a cluster if I were the user, right? Like, what would be my impetus for using it? Like, I know why I
mean, that's certainly valid. But I guess my feeling was, I mean, do we need to have a strong feeling or an answer in order to implement a feature like this? Like this feels like something that would be very much up to the user and their specific needs.
Right. I mean, I think we should have a strong user story, right? Which I think we have a decent user story, but I think like, yeah, taking it to the level of the UX, like having a user story that's grounded in like, like I have a user who's doing this currently, I think makes it a lot more tangible. And now that said, like I'm not trying to dismiss the work that's here because I haven't read this issue in quite some time. So like I couldn't, I'm not trying to say that at all.
Okay. Well then, is there anything that I can do to help drive this forward then? Yeah, pretty much I am seeking a resolution to this GitHub issue. Whether it's this node pool field that I'm proposing or something else, I'm open to that as well. But how can I help resolve this? Or how can I help push forward my RFC?
I guess the question is, are we at loggerheads here in terms of like, do we have consensus among the community that this is something we want to go forward with or not? Because it seems like right now we're having trouble making up our minds if we want this or not.
Yeah, I think so. I know, like Derek's mentioned, this has been something we've been thinking about quite a bit. We definitely for ourselves want to get some strong data for like what the effect, like how predictable is this type of configuration knob? What actual effect does it have on clusters of different shapes of different scales? Because yes, it is a user choice to configure it, but if it's unpredictable because of some of the second order effects, it doesn't necessarily make it a good user experience. And it might be very predictable, and that might not be an issue. I think it's one of those things that would be hard to tell without a POC and data collected based off that POC. Um,
I mean, it sounds like you're kind of laying out the steps for Isaac here. So, Isaac, if you want to know how to really accelerate this, it sounds like if we had some data to help evaluate the predictability of how this works, like that, it sounds like that would help. That would help kind of break things up here, break the logjam, as it were.
I think it would help because I think the hardest thing about these features which inject into the algorithm is it's a complex algorithm. It's very difficult to reason about what actual effects this has in real clusters and not just smaller contrived scenarios.
Yeah.
So
To that level, though, that almost gets into kind of like perf and scale kind of testing. I guess, Isaac, how do you feel about the notion of coming up with some data based on the proof of concept and everything?
Yeah, I could definitely do that. If one of you could maybe comment in the RFC or anywhere, even in the C tree, about maybe what specifics you're looking for. I can definitely gather some of that. Like, do you have any initial thoughts there? Like, what when you say predictability, what do you actually mean there?
that's what I think we're still trying to work out exactly how to define that. I mean, it's why we haven't necessarily moved on this quite yet. Trying to figure out what the evaluation criteria need to be to determine this is the right path to go forward with that will be the best user experience. Yeah, I think it's something I don't have an answer for right now and would need to think on.
Yeah, I think
But
at a
then,
very, at a
but
very,
then how do I move it? Like, you
yeah, I
you
think
have
at
to
a very
recognize what
cursory
that means.
level, yeah, at a very cursory level, Isaac, like, sorry to interrupt, but like at a very cursory level, I think the notion of predictability here is like we know what we want this thing to do, right? We know how we expect it to behave when we're using this because we would hope that it would answer the issue that's open here, right? So like if we turn this on and we can demonstrate that it predictably behaves the way we expect it to at varying different sizes of like, cluster size and workload size, I think that starts to add confidence to say, okay, this probably is the right way to go. But that's the tough part right now is that I can tell, like, obviously it's difficult to enumerate what that will be, but I think looking at the issue here, we know what the expected behavior would be, right? If this feature were available and I could help to eliminate, this kind of like underutilized disruption, I should be able to measure that at some level and say, okay, here's what it looked like beforehand. Here's what it looked like after I put this feature in, and then here's what it looked like at different levels. Like when I set the varying levels of whatever, the value for the cost ratio or whatever. So I think if you could demonstrate that, it sounds like that would help to build a lot of confidence in the community here, at least.
Okay, yeah,
Does that make sense though? I
yeah,
guess.
that can totally be done. Yeah, it was just confusing the other part of it, but yeah, that can definitely be done.
Yeah. So what I would focus on too is like the notion of testing this on like small clusters is one thing, but if you can test it on larger clusters, with like 50, 100 nodes or something like that, if you can do some sort of density testing, I think being able to show it on a small cluster as well as being able to show it on a big cluster, and then showing that the behavior before turning on the feature and the behavior after turning on the feature over like several runs, if you could demonstrate that through data, you could say, look, like we saw this happening, or we were able to induce, I don't know, like overly high amounts of pod churn if we did X, Y, and Z. Being able to enumerate some of those things definitely makes this a lot easier to make a decision about. Because I get what Jason's getting into, like the the algorithm is so complicated that at some level, once you start changing things, we need really good data to evaluate that this was what we meant to do with it, and that we're not making corner cases or whatever, right?
Yeah. For example, like I think in the ideal case, what we would see is you set your price improvement threshold to 80%, your cluster is now 80% utilized, and we make sure we drive it to that or to 90%. That would be like the golden case for predictability. My fear is we don't quite reach that. And it might be hard to reason about, like based on a price improvement factor, what you actually land at as your steady state. But that's one of those things where it's tough to, like, unless we actually had a mathematician come in and model, like, I imagine you can model Carpenter through a set of differential equations. Unless you had someone who wanted to come through and actually do that modeling, I think it's going to be tough for us to predict what what the effect of this would be without a POC.
Right.
I mean,
Yeah.
I don't want to.
Go ahead, Isaac.
No, that was me. Yeah, I don't think we need diffie-q equations to get there for this. I do think some base cases would be useful to get the data on.
No, yeah, I didn't mean you had to go make diffie-q, but I just meant like if you wanted to empirically prove that this is the effect it will have in all scenarios, I think that's how you would have to model it. But yeah, I'm not saying we need to do that.
Okay. Well, yeah, I can definitely do a POC to show that this reduces no churn by X amount and maybe a few other things. But yeah, if there's any particular data that you're interested in seeing, I'd really appreciate if anybody could write that down somewhere.
Yeah, I think the main thing off the top of my head, at least, is how closely the disruption, like the price improvement threshold, matches to like cluster utilization. Because that's kind of the hard thing to reason about for users is we want it to be more than a magic number.
But
And
it's not necessarily, or so because clusters fluctuate, right? Like with the number of pods or like workload scaling up and down based on whatever. It doesn't necessarily track directly to utilization. It would track to, I think the real measurement would be around node churn. And like how frequently you're adding and removing nodes.
yeah, but I think if you set the problem is that's not what people are going to expect when you set a price improvement threshold. Like that's when you set a price improvement threshold to like 80%, you're going to expect that, okay, my cluster is going to sit around 80% utilization. Of course, at steady state, if you have a churning cluster, it's not going to be exactly at that all the time. But that's kind of the predictability that I was talking about.
I think
I don't-
that at
I
this
don't
point we're
necessarily-
kind of going around in circles. I think like it seems like there's a clear thing that Isaac can do here to help, add more confidence to this and whatnot. And like I'd say go do it, Isaac. Like you put the POC together and show us some different, outputs of how it works and whatnot, and then we can get to the next level of this, right?
Sure.
Yeah,
That's
we can
good.
always change the name afterwards, but I think the data is more important to get going now.
Sure. Yeah. I mean, once we have data, I think we can have better, more informed conversations.
Sure, I can do that.
All
Shall we
right
move
then.
on?
Yeah, that was a good discussion. Moving over to the next thing, autoscaling pod conditions, KP.
I put this one in here.
Okay.
This is more of an FYI for folks to read it. It was proposed for CAS, but it should apply to Karpenter as well. Folks want to add new pod conditions to for autoscaling. Basically, like when instead of just unscheduled, there's also like autoscaling in progress, and like you can see the condition of a pod if you're launching a node for it in progress and stuff like that. I think it was very much written for CAS. I think we're going to want to weigh in as Karpenter users on how we want this to look for us and how it applies to Karpenters. The best view is like, yeah, proposal down there, node provisioning in progress condition, where you can see like, oh, this pod is unschedulable, but also we're waiting for a node to spin up for it. It also will be a place to put feedback on like the node launch failed for these reasons, so that way you could see why your pods don't remain unscheduled over time. It seems like a good proposal to me. I don't see why we wouldn't want to surface this observability. The question is just making sure that the labels and the conditions and stuff read in a way that makes sense for both Karpenter and Cluster Autoscaler. So
Yeah, for context, this was brought up at the SIG Autoscaling meeting earlier. I think Derek was there. But yeah,
Yep.
like the author's looking for some reviews and feedback at this point.
All right, I guess we're just looking for feedback on this one, right? So, um,
Yeah, it's not as large of a discussion as
mhm.
consolidation thresholds.
Yeah. All right then. Moving over.
Yeah, that one's mine. So I talked about this, 2 weeks ago in the previous working group, but I opened RFC for node limits for node pool. I know Garvin, you already put a comment on there a few minutes ago or an hour ago, and I haven't looked at that yet. But anyways, yeah, just wanted to get more, feedback on it from contributors and maintainers on this. Just basically implementing, a hard limit for nodes in the spec limits of the node pool. And yeah, if anyone has any questions, let me know. But just generally looking for feedback.
I think we can just quickly try to understand what was your use case for this. Like,
Yeah, so my particular use case is that we provide Karpenter as a service provider, under the service provider, I guess, persona, similar to EKS. And we have certain SLAs that we don't know what will happen to our cluster or the user's cluster if there's nodes provisioned over a certain limit, for example, 500. So we just want to prevent, the user from creating more than 500 nodes in the cluster, because we cannot guarantee like horrible things will happen if we go over that. So that's our simple use case. But I know there's, a lot of other use cases for this particular feature.
Yeah, I think we've talked at length, I think, in previous working groups about the use case, and I think we're all aligned that it makes sense. I haven't had a chance to read the RFC yet. I will definitely try to, like, over this next week. But the one thing I know that, at least if we did hard limits, that I'd want to see us possibly address is how it interacts with like consolidation and drift. Like right now, you're in a state where if you have hard limits, you essentially can't do either of those operations. Is that something you've addressed in this RFC with hard limits?
Yeah, so basically I just said if we're at the limit, like, say the limit is like 25 nodes and we're at 25 nodes, consolidation and drift just don't work. Because yeah, that's the simplest like thing to implement right now. I know there was discussion about how if we could have a way that we could terminate the nodes before creating new nodes, then we could solve this issue. But Karpenter doesn't work like that right now. We have to create new node claims and get the nodes to be ready before terminating the old ones. So my particular implementation right now or proposal is to just not have it work, or it'll just get blocked when we try to drift or consolidate.
Yeah, I suppose the other way you could kind of prevent people from getting stuck with this is have like a mix of soft and hard limits. That way you ensure that you always have some bursting room at your steady state.
I think it, at least in my mind, it makes sense, but I think we should, at least for the start, to scope that out so that at least right now we can implement hard limits, and any launch before terminate pods will get launch before terminate would just stop at the limit, and then we can follow up with like a, because I don't know if everyone wants that feature. So I'm wondering, like, as a follow-up, we can turn on a feature or a variable, say launch before terminate, or flip over to terminate, then launch when hit limit. But that can, in my mind, that can come later.
Yeah, I
Yeah.
agree. It doesn't need to be scoped in here. I do think we need a solution to ensure that those features can work in conjunction with hard limits, because that's a bit of a sharp
Yeah.
edge case.
Yeah.
But I think if you just had a mix of soft and hard limits, at least to me, like just speaking for myself, that seems like an acceptable state to be in. Like if you just set hard limits, you could get stuck, but if you set a soft limit, that's like a couple under your hard limit, you'll always have some bursting room at steady state.
Yeah, that was actually my comment. I think right now you're taking over the limits for nodes from soft to hard, and my comment was simply like that changes the existing behavior, and you would have a mix of behaviors and limits because I'm guessing pods limit and all the other resource limits not exactly hard. So it might be worth creating a brand new variable that's like hard limits or something different so that we don't override the existing behavior, if that makes sense.
Yeah, existing behavior today, all limits are soft.
Right, yeah,
The
okay.
exception of static capacity.
Right. So it might be worthwhile changing the like don't use the existing limit and come up with something new for the hard limits. Yeah, I think that was my only comment on the RFC.
Yeah. Yeah, I think that's, like I said, I haven't had a chance to read it yet. But I think that is the one thing I would personally like to see addressed, is how we can ensure that people who need to use hard limits can still make use of features like consolidation and drift.
Okay, that makes sense. So when we're speaking about using both, are we saying that we want two separate like API fields for this, or are we saying that we should have one and then swap over when, you know, we're at the limit or something?
I mean, two different API fields is an option. Like I haven't thought about it through enough to prescribe like this is what the API should look like. But yeah, the thing that seems easiest to reason about is separate soft and hard limits. I mean, that's similar to like separate soft and hard eviction thresholds, for example, on kubelet.
Okay, yeah, that makes sense.
I don't know if
So
anyone else has any thoughts on that.
just a quick follow-up question then. Does that mean that we might need like a separate RFC to implement the soft, or, you know, not a separate RFC, but just an extension on this is to implement hard limits for all the other resources that we currently limit, you know, like CPU and memory, or because I don't know if we just want to limit nodes for now, hardly, but like,
I don't know if
you know what I mean?
I don't know if it's necessary. I think that would definitely be what we want to extend to. Like if you're supporting hard limits for one resource, you should support it for all, just from a parity and predictability standpoint.
Okay,
Uh,
no, sorry, go ahead.
yeah, I also think there's probably a use case for it. Like if you say this team only gets 8 GPUs, that's the most GPUs they can have at any given time. You set a hard limit on GPUs, stuff like that.
Right. So for now, it's okay for this. Well, I don't know if we're gonna accept this, but for now, it's okay for the proposal to just be about node hard limits and not hard limits for other things. Is that correct?
I don't think it would necessarily be a blocker. Unless it's adds a lot of complexity, I think we should include both. And I don't think it would add a ton of complexity. And it would be good to at least understand, if there is complexity, what is the path to including both in the future? My personal opinion is that it doesn't necessarily need to be a blocker, but like I said, I would like to get other people's opinion on that as well.
Yeah, I mean, I think starting with nodes is probably a fine way to start, and then like having an evaluation of how tough it might be to add the other ones is probably good for the RFC. But like, I think it'd be okay to start with node and then, you know, see if we want to add, like adding CPU and memory makes less sense to me, but like adding out the hardware, adding like hardware accelerators and special stuff like that, that makes a lot of sense. So I don't know. I think it's not a blocker for me to start with node and then expand it later, but having an idea of how difficult it would be good.
Yeah, no, that's what I'm more interested in seeing, is just what would be the path to expanding it, rather than like we need to include all in an initial implementation. But at least making sure that we've thought through the path of, okay, this is how we'll expand it to be more at parity in the future.
Okay, so more of a, I guess more implementation details will be helpful here. Well, I know you didn't read it yet, but
Yeah, like I said,
if you were to read it and that wasn't there, that would help.
Yeah, I mean, at like a pseudocode level.
Right.
If even that, really just more so like, okay, this is how we evaluate these different hard limits and consolidation and drift. Like in all of the different places we need to evaluate limits, which I think just collapses to the scheduler, but
Okay, that sounds good. But yeah, everyone, if you would like, please take a read at that. And I think I have a little bit of pseudocode in there to how I would implement it today, but yeah, thanks for the discussion.
yeah, great. Thanks for bringing this up. Like I said, I'll make sure to read this in the next, at least the next week.
All
right.
right.
Just a little bit late to the party on this discussion. Did you see the upstream cluster autoscaler cap for, I think it was like cluster limit range or autoscaler limit range that was kind of overlapping with this cap? I can try to pull it up.
I think we just talked about that right before this,
Okay, sorry.
No, that
about
was a
but
that was a
is
different
that
cap.
something different? Okay.
Yeah, we talked about
Yeah.
that last working group about the if you go into the log, I think there's a link there where it's the I think we talked about it. Oh, maybe not. I've got the link handy. It's like a cross node pool limit people are talking about.
Can you share it in the chat, Derek?
Yeah, we were
Yes,
chatting about
1
this, Derek,
second.
right? Do you have the link still? Trying to find it.
Yes, I do. I thought these would be two different issues considering one is on a node pool level and this is cross node pool. So I think they serve different functions, but they do intersect in a way.
Yeah, like if we did support this, we maybe wouldn't need it on a per node pool basis.
Yeah, because you could just
Yeah.
scope these to a node pool. You might still want node pool per node pool limits is the thing. I don't know if the autoscaling limit range API would let you scope it to a specific node pool.
But the
And if it
match
does,
label
it kind
could,
of
right? Maybe.
yeah. I don't know if I love that API as a like customer experience if you just want a very simple. I mean, this API was built, the autoscaling limits range API was seemingly designed with cluster autoscaler, coming from the cluster autoscaler perspective of they already have per node group limits. And so they want to add cross node group limits.
Well,
I don't know.
they currently have global limits, but they're not granular like this. Like you can't get into just saying like I no more than so many of this type of instance. You would have to put that into a node pool, into a node group, and have a limit there. And so like then every node group that you had that had that type of instance, you would have to put those limit. You would have to calculate the limits between them. So what they want to do is be able to have a global limit on that kind of stuff, right?
Yeah, I think the point of this API is you essentially can slice and dice it as much as you want. Like you could do it by you could write a selector that would scope it to a node pool, or you could have it be global, which I know is like a long ask in the Karpenter ecosystem. And then I think in here there was also like node. Node is a resource if you scroll down a little bit. Yeah, there it is, node 50. It maybe doesn't like I mostly just want to make you aware of this proposal. I'm not sure we're like convinced about it yet. There's maybe some benefits to the flexibility, but also there's some extra complexity with that flexibility. But the interesting piece to me was more than just resources. It was also treating nodes, putting nodes into this picture. And I guess whether or not it's like resources or nodes, you also have this like launch before terminate. Like how do you even make progress if you're at your limits and you can't like do rolling upgrades anymore? Which is kind of true for nodes and true for other types of resources.
I would say I kind of like the flexibility of this one, for better or worse.
Well,
Yeah.
I would say that this, sorry for cutting off whoever that was, but this would solve our particular use case. But I know this is still under discussion. But I still think it might be useful for having a per node pool limit on nodes as well, since it's not formally supported. But I I mean, this API would definitely cover my use case.
Yeah. I think either way too, though, the semantics of like, this is how hard limits and soft limits behave that you're describing in your RFC apply regardless of where the API actually lives.
Right.
Like
Yep.
this is the API definition, but not necessarily. Like I assume that we're not expecting Karpenter and Cluster Autoscaler to behave exactly semantically the same based on this API definition.
No, fair enough. Yeah. We still need to define the behavior if we were to, apply this. So
Yeah, just regardless of where the API lives, node pool or here.
All right then. Unless there's anything else left, we are almost at time. So one last call for if there's anything that someone wants to bring up.
I did want to ask, Isaac, are you in the Kubernetes Slack by any chance?
Yeah, I am.
Okay, perfect. We can start a thread on the Karpenter channel or the Karpenter dev channel or something together to talk more about the kind of data we're going to be looking for your proposal. I think that makes sense.
Yeah, that'd be great. Thank you.
All right then, sounds good. Thank you everyone for joining.
Bye. Have a good one.
Have a good one.
Thanks.